Hello again. Well, I do apologize because this chapter is so much more fun when we're playing with rocks and playing with minerals. I'm sorry it is mostly vocabulary words of things that you'll probably never touch unless you get interested in rocks and stuff. They are interesting. I had one daughter who went into geology. But if you remember yesterday, we found out that the minerals have an exact ratio. They're naturally occurring crystalline solids that are the result of a geologic process. We found out that the mineral has to have its atoms and its elements in an exact ratio, that the atoms are arranged and how they're bonded together determines whether or not it's a strong mineral or a weak mineral. Um, if you have a whole bunch of elements, maybe you have a magma flow that's come and it started to solidify and it's made up of all sorts of different elements, not in exact ratios. You still do have a solid surface, but you don't have what we call a mineral. You have a rock. And that's what next chapter's on, but we'll get to those. So here's some things that we know. We know how minerals are formed. We said that they're formed with cooling magma or lava. We know what makes a mineral and not a rock. A rock is elements that are just not in exact ratios. We know the different types of minerals. We looked at the chart on the beginning of our reference tables and found that oxygen and silicates are the most common minerals, and that oxygen is in a lot of the eights and ides if you look at the different names, carbonates and such. We know a whole bunch about minerals. We know how they formed. We know how their strength is determined. But how would you figure out what a mineral was if you came across it? What tests would you run in order to do that? And so I have to ask you a question. And that question is, how would you describe a pirate? Now, you're on COVID-19's exciting time at home. Hopefully you have not just stared at the wall and mumbled incoherently. Hopefully you've done something like going outside, or maybe you've watched old movies. And I do like the Pirates of the Caribbean. I know they got really, really awful as they went along, but when they first came out, they were really good. So think about all the pirates that are on that. How would you describe them? Would you describe them by their dirt, whether they're male or female, whether they have legs, whether they have eyes? Yes, one eye. Would you describe them as if they were handsome or beautiful, or what would you use to describe the pirates? So when I describe pirates, I need to narrow my answer down. I need to describe specific pirates. Male, female, long hair, short. You need lots and lots of details because pirates come in all shapes and sizes. Excuse me. Some you wouldn't want to be around. Some you might want to be around. Some you'd run from. Some you'd run to. I don't know. There's a lot of different pirates. So the more descriptive adjectives that you can use, the better you can describe pirates. There's your favorite, I'm sure. So that we do the same thing with minerals. We use several different tests to identify minerals. And so if you would, consider the following slide. If we only test with one test, say we use the test of color, these three rocks, well, they're not rock, well, they are rocks, but they're also minerals. These three could be considered white. That's not going to help me a lot. If you go outside and you look at rocks, you'll find there's a lot of rocks that are the same color. So how do I identify minerals if I just use one test? Same thing with the idea of all things that can fly. Well, what sorts of things could they be? They could be things that man made, like airplanes. They could be blimps. They could be the airplane you just threw. They could be natural, a bird, a bat, all those guys. as we divide into smaller and smaller sections, we can narrow down our answers to find out what is a mineral. So the first test that we do is color. I know that's really hard, but one of the things that I do want to write down next to color is that you have to be very, very cautious because many minerals have the same color. So next to my identifying minerals on my notes, I'd write caution, many have the same color. So we can't just do one test. The second test we look at is streak. And it got me thinking, you know, I know you guys can figure out the pirate running down the beach with all the natives chasing him. That would be streaking down the beach. But does anybody get the reason why this naked guy just went flashing across the screen? Now, he was appropriately pictured, so you don't have to go back and check that out. But back when I was in late elementary, early middle school, they started a phenomena that I think still goes on, and it happens when they have really big baseball games or football games or some sort of sporting event, that some crazy fan will jump out of the stadium seats and will run across the field with all the security guys chasing him, and he'll be absolutely naked. That's called streaking. And it started way back, like in the 70s. There's even songs about streaking. But that's not the kind of streaking we're talking about for finding the streak of rocks. When we find the streak of rocks, we use this little plate, and it's made out of pretty much the same stuff that a regular plate is made out of, except it's not glazed. So we take minerals and we scratch the mineral onto this unglazed porcelain plate, and if it leaves a mark, that tells us something about that mineral. Some minerals will leave a reddish mark, some will leave a gray mark, some will leave a white mark. In fact, there's black streak plates too that you can use. Some will leave a no mark at all. All of those are helping us to narrow down what kind of mineral we have. It's called streaks, and we use a streak plate. The third test we use is luster. Now, before you start writing everything in the world down, the only thing you need to write down is what I have underlined. Luster is how well a mineral reflects light. And you can see there's a whole different categories of ways things reflect light. And that makes sense to you, doesn't it? If you shine a flashlight at a wall versus shining it to the ground versus shining it to a metallic surfaces, you know, how something reflects light definitely can give you some indication of what that thing's made out of. And the same thing happens for minerals. Now, there's a whole bunch of them. There's dull, there's earthy, there's fibrous, there's greasy, there's all sorts of things, but we don't use all of them at the earth science high school level. You'd have to go and take geology in college in order to be differentiating between all of these guys. At the high school level, all we use is it metallic or is it non-metallic? And by metallic, I mean it looks like metal. If you saw it from across the room and you weren't sure what it was, you would think, oh, there's a lump of metal. It's very shiny. It reflects light very well. The non-metallic ones don't. They look like a rock. So these are the only two types of luster that we use, metallic and non-metallic. The next one is crystal shape. And crystal shape really helps us to understand where did these crystals form and how strong they are. So as you can see by these pictures, there's some really funky different ways that crystals can shape. Minerals and rocks are just really fascinating when you start getting into them. I wish that you were here. I have so many different ones that I'd love you to see. Just because of their beauty. They are just beautiful things. So, crystal shapes. So, crystal shapes, they are the shape of the specific crystals in there. And when I look at a crystal, if I see that I can see really nice big crystals, I know something about that mineral. I know that it's formed underneath the ground. And why do I know that? Because when it's underneath the ground, it is cooling very, very slowly. And that slow cooling allows the minerals to get, allows the crystals to get very, very big. So if I find a mineral and I'm looking at it and I can very easily see the crystals, I know I've got something that's formed under the ground, and it is formed with cool, slow cooling. So on my line, on my notes, I have slow cooling, large crystals for crystals that form inside the earth. Crystals that form outside the earth, they cool very fast. You've seen the pictures last chapter of the lava spewing out of the volcano and hitting the water and immediately turning dark because they're solidifying. If there's a real rapid solidification, then the crystals don't have time to grow big. They're going to be very, very, very small. Some of them might even be so small that you use a microscope in order to see that there's actual crystals there. On my line for crystals forming outside of the earth, I have cools quickly, small crystals. In fact, this next slide will show you ones that the crystals are so tiny that you definitely need a microscope to see. And that's a picture of obsidian. We call it glass, and you can add that to your line too, that glass is a mineral that has no visible crystals. You could see them with a microscope, but you can't see them with a naked eye. And the other thing about obsidian, when you see this is a really good sample of it. If you notice as you're looking at it, it almost looks like it has the imprint of a shell on it, a shell making curving lines on it. That's a good indication that this is obsidian and not a lump of coal. A lump of coal would not have those curved lines on it, but that's ahead of our game. So as we go through all of these things, what we're trying to do is trying to be able to identify what minerals are what. And so we've looked at color, we've looked at all these other things. And I want to leave you with graphite and diamond. Graphite and diamond are both made entirely out of carbon, both of them. And yet, because of the way the atoms are bonded together, because the arrangement of the atoms inside of them, diamonds can be used on drill bits, can be used obviously with jewelry, but can be used in industrial means to, it's just one of the strongest things that we have. And yet graphite we use in pencils, we draw with. Both of them are made out of the same material, and yet their characteristics, the shape of their crystals, all the different factors, how fast they cooled, determines what type of mineral they're going to be and the properties of those minerals. Well, I leave you with that. I have a little bit of homework for you and a video. I do want to apologize. I try really hard not to say rocks when I mean minerals and minerals when I mean rocks. I think I'm trying to talk too fast. So all in this chapter, if I ever say rocks, I really mean minerals, and I think I need a Diet Pepsi. All right, guys, have a great day.